Hi guys. Welcome to my channel Cybernetics. My workstation consists of 3 wall-mounted shelves. The lowest and largest shelf functions as a table. This is a video about designing flexible LED lighting for my workstation. At first I plan to keep it simple. I have 4 switches, with each switch connected to a LED strip. They independently turn on or off the 12 volts power supply to achieve the desired amount of light. But since I have an Arduino Nano board, a DC power converter module, a 4 relay module and some rotary encoder knobs, I want to make things complicated, with a simple and interesting control interface. I will upload code to the Nano board to enable the use of a rotary encoder to control 4 LED strips to illuminate in a specified sequence. First, I install the Arduino Integrated Development Environment into my Windows 7 system. Then, I install the driver for the Nano board. Driver CH340 of the USB interface chip on the Nano board has been installed successfully. It is displayed in Device Manager like this. I launch the Arduino Integrated Development Environment, and a text editor window automatically appears with the name, Sketch_Deck22A. To verify the normal operation of the Nano board, I use the Blink program from the available library. Adjusting the time parameters a bit. Once uploaded, this program will make the LED D13 on the Nano board blink at a frequency of 1 Hz. The LED is blinking, so the Nano board is functioning properly. I have stuck 3 LED strips to the underside of the middle shelf. For the remaining LED strip, I solder the power wires, insulate them, and then stick the strip to the underside of the top shelf. I attach the Nano board, rotary encoder, and 4 single LEDs to the breadboard, with each LED representing a relay control signal. When the digital output signal from the Nano board is low, the LED lights up, and when the digital output signal from the nano board is high, the LED turns off. The microcontroller program that creates an interface for the rotary encoder can be found in various sources of documentation and videos on the internet. The structure of the rotary encoder I am using includes an encoder wheel and a push button. Therefore, the code for the nano board comprises a segment for decoding the rotary encoder and another segment for capturing button press event. I referenced the code for the push button from another source. I combined intuitive thinking and logical analysis to create the remaining code, making it concise and elegant. Both code segments exhibit quite effective debouncing functionality. Consequently, the generated relay control signals are clean. I solder the buck power conversion module and the 4 relay module onto a perforated test board with dimensions of 9 by 15 centimeters. The nano board is connected to the bottom left corner of the test board using 2 rows of round pin socket connectors. The rotary encoder knob is connected to the test board with 2 power wires, red for the 5 volts and black for ground. The 3 signal wires, S1, S2, and key, are colored purple, green, and white, respectively. You can see, 4 5mm black round jack sockets are used to supply 12 volts power output for the 4 LED strips. The yellow covered dual connector is the input for receiving a 12 volts DC power source. The orange plastic pieces are 8 spacer rings created using a 3D printer with PETG material. They are used with M3 bolts to slightly elevate the 2 modules above the test board surface by a few millimeters, facilitating easy wire soldering. I transform a plastic jar into a transparent case for the circuit. I drill several holes on the lid of the jar. 2 holes for the power lines in, 4 holes for the power lines out. I 3D print 2 parts using PETG plastic. 1 part is installed to support the circuit board like this. I use M3 bolts to fasten them with the corresponding nuts. One part is for supporting the circuit board and attaching it to the lid of the jar. For this part, I use brass threaded inserts instead of M3 nuts. I attach the completed case to the underside of the middle shelf using Velcro tape. I also do the same with the 12 volts DC power supply. Velcro tape is really suitable for this type of application.